Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the nominal function in Excel to convert from an annual effective rate to a different effective rate. In any intro class, you will need to be able to convert between different effective rates, and we professors will both test you on this directly and also create questions where converting to a different effective rate is the first step. If you want to ace those questions, or at least the first step for some of those questions, this video is for you. I have prepared a question up here where we are given the annual effective rate and we need to find a different effective rate because we have a loan with monthly payments, and so we need the monthly effective rate. Now, to get started for any interest rate type conversion question, we want to take this verbal description and put in the correct values. So our annual effective rate is the 4.5%, 0.045. Our number of periods is the number of months in a year, because we want to go to the monthly effective rate, so we need to do 12. And then we need to find the APR compounded per period, the nominal rate with monthly compounds. And so this is where we use the nominal function. Equals nominal, and our effective rate is the annual effective rate that we put in 0.045, and n per y, number of periods per year, that's number of months per year, that's 12. And so that gives us 4.41%. That is our APR compounded monthly. Now we can always take an APR and find the equivalent rate. In this case, it's going to be the equivalent monthly rate because it's compounded monthly by dividing by the number of compounds per year. So if we divide this by 12, we're going to get 0.37%, which is our equivalent monthly effective rate. Now, if we want to be a little fancier, use better Excel practices, and most importantly, be able to take this file and reuse it for future questions, we can use cell references. So instead of typing everything in directly, we can use this little table we've already created. So now I'm going to go and say, instead of hard coding in my annual effective rate, I will tell Excel to use B4, where I've entered my 4.5%. And number of periods is 12 and B5. And then here, instead of using just 12 hard-coded, I will use number of periods. And as you can see, I still get that same 0.37%. But now, if I need to change either of these parameters, I can do that and my effective rate will immediately update. So for instance, let's say our question is not asking for the monthly effective rate, it wants to find the quarterly effective rate. We can just change the number of periods. There's 4 quarters a year. And our new quarterly effective rate immediately updates. We're doing a two-step process here. We use the nominal function in B6 to find an APR compounded by whatever number of periods we need. And then we divide by the number of periods per year to get our new effective rate. This is a different approach than the algebraic method that we sometimes use to convert between effective rates, but it is elegant and an easier approach if you're trying to avoid algebra, which, if you're looking at this video, you probably are. I do find it helps to break this down to do this one step at a time, first finding the nominal rate, then finding the effective rate. You could do them all at once in a single cell, but that can be a little bit tricky. I have a separate video where I cover how to use a nominal function all by itself. The link to that will be in the description. That video will also be in the playlist along with this one. So with this single nominal function, you can take any question that asks you to use an effective rate and convert to a different effective rate that your professor might be throwing at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find it too. Happy studying.